In this video, we are going to watch how to solve a linear programming problem graphically in Microsoft Excel. So here are three constraints and an objective function to minimize z equal to 4x plus 2y. In order to find the coordinates of plotting the graph, let us construct a table first with the constraints, which is x and y. Here goes the objective function z, the constraint c1. Hold on to cursor, drag it down for the constraint C2 and C3. Now, let us enter the coefficients of the value of x and y values in the objective function and the constraints, which are 4 and 2. Here it is 1 and 2. For C3, C2 it is 3 and 1. For C3 it is 4 and 3. And then inequalities are greater than or equal to 2, greater than or equal to 3, greater than or equal to 6. Let's draw the table. Yeah. In order to get the coordinates, let's consider a variable as x and find the value of another variable. So let's consider C1, x, and y. So in the constraint 1, if x is 0, then y will be 2y equal to 2. And y becomes 1. If y is 0, x will be 2. Let's construct this also as table. Now, so this is C2. These are the values of C2. So in C2, if x is 0, y will be 3. If y is 0, x will be 1. In C3, if x is 0, y will be 2. If y is 0, then x will be 6 by 4, which is 1.5. So now we have found the coordinates. Let us plot the graph using these coordinates by using insert option. Bring on a graph. So here there are, so this click, give a right click anywhere on the graph in order to select the data. And remove these series. So now adding C1. In order to get the values of x of C1, select the values of x and C1. To get the values of y, select the values of y in C1 and click on OK. And adding constraint 2, select the values of x in C2 for x values and select the values of y in C3 for y values. Click on OK. For add, let us get the values of C3. To get the values of x, select the values of x in C3. And to get the values of y, select the values of y in C3. Click on OK. And OK. The graph has been plotted here with the constraints C1, C2, and C3. The blue line is C1, the orange line is C2, the gray line is C3. Now, since the inequalities are greater than, the region will be shaded upwards from the lines. This is C1, so the region will be shaded upwards in this direction. From blue line, the region will be shaded upwards in this direction, and from gray line, the region will be shaded in this direction. So the feasible region will be this. Let us Shade the feasible region using freeform tool. Click on the intersection point and take it to the end point. Click it there. Take it to another end point. Click it there. And click it. Yeah, this is the feasible region. Let us make it a little transparent. Hope you are able to see the feasible region. Let us mark the feasible regions. Intersect by using the names. Changing the style. So this will be point A. This 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 and just mark the intersection points. This is A, this is B, and yeah. Now we need to find the ordered pairs of A, B, C in order to find the objective function. Since the objective function is to minimize it, we'll be taking the least minimum value as the value of Z. So let's find the values of A, B, C. That's the point A. In order to find the XY values of point A, I'm considering C1 and C2 constraints. So let's find the value of X, Y, and Z. To get the value of X and Y, select the cells beside them and click on this mathematical function M mult, which is add matrix multiplication. Open the brace, M inverse, open the brace, and select the values. Close the brace, comma. Select the values after the inequalities. Close the brace. Now click on Control plus Shift plus Enter for the values of X and Y. After this, yeah, this will be our point B. This will be our point C. So let's find out B using C2 and C3. Let's find out point C using C1 and C3. C2 will be 3, 1, so it's 4, and you can see the values changing. So it's 3, and this is 6. Yeah. So value of C1 is 1, 2, 2. Values of C3 is 4, 3, and 6. Yeah. Now let's find out the value of Z using equal to. Since the objective function is 4x plus 2y, we'll be multiplying the x value with 4 plus y value with 2. 4. Open the brace. Close the brace. less 2 into, open the brace, follow option. Click on enter for the answer. Now the same applies here. Equal to 4 into, open the brace, select the value of x, close the brace, less 2 into, open the brace, select the value of y, close the brace, click on enter. The answer is 4.8. Again, equal to 4 into, open the brace, select the value of x, plus 2 into, open the brace, select the value of y, close the brace, and click on enter. Since the objective function is to minimize z, the least value among the points A, B, C is 4.4. Thus, the value of the objective function, which is minimize z, is 4.4. Hope you understood. And this is the feasible region. Thank you.